So we can find the average of a probability distribution, which is what we just did on the Powerball. We called it the expected value, but that's an average. So if you can find an average, then you could also find things like the median, the mode, or even a standard deviation. So we will look at the mean, the median, and the mode. We're going to skip the standard deviation for now, because as we'll see soon-ish, whenever we get there, the next little bit, the next concept, there's a shorter way to do the mean and the standard deviation, so I'm not going to show you the long way. Oops, bumped my camera. Alright, so here's another example. We're interested in passing a driver's education test. So our random variable is how many tries did it take the person to pass their test. So we have a sample of 50 students, and we see that some of them took 1 time, 2 times, 3 tries, 4 tries, up to 5 attempts. So what we have are their frequencies. So out of the 50 people, 30 of them only needed 1 try. Pretty good. 10 needed 2 tries, 5 needed 3 tries, and so on. 2 people out of the 50 needed 5 tries to pass. So we can convert these frequencies into relative frequencies, or, as we've been calling them, probabilities. So what's the probability that if we randomly picked one of these 50 people, that they would take 1 attempt? Well, there were 30 of them that needed 1 attempt out of the 50. So the probability is 30 over 50, or 0.6. Or if you like percentages, that's 60%. So we have 60%, 20% needed 2 attempts, 10% needed 3, 6% needed 4, and 4% needed 5. And these all add up to 100%. So back in, say, chapter 2, if we wanted to find the mean, median, and mode, then we would need the data. Well, we know the frequencies, so we can write out what the data looks like. But that's not really elegant, I guess I could say. So we have a bunch of 1s, quite a few 2s, not many 3s, a couple 4s, and only 2 5s. So we could add these all up, and we could divide by 50, and that would give us the mean. We can kind of look at this and see the median. Oh, the median is probably like here, somewhere in the middle. So the median should be 1. In the mode means what value of the random variable occurred most often, and we see that that's also 1. Okay. Now, we don't have to write out the observed data. I'm going to show you how to use the probability distribution, which is what this table is. If you omit the frequency column, it's used to get the probability, but it's not typically part of a probability distribution. How can we use this distribution to find the mean, the median, and the mode? So one thing you can also do, if you don't like the tables, is you can visualize the probability distribution. Since we have a quantitative discrete variable, we can create a bar chart. So what we have on the x-axis, that's the number of attempts, little x, and on the y-axis, the height of each bar, that's the probability. So we see that the highest probability is when, is for people who only needed 1 attempt. And then as we go down, the least likely result is that someone needed 5 attempts. So how can we use this or the table to find the mean, the median, and the mode? Well, with the mean, again, what we're going to do is we're going to take each little x and multiply it by its probability, and then add them all up. So, to do that, we start with our first little x, 1, and we multiply it by its probability of 0.6. So we have 1 times 0.6 plus the next one. So next we had 2, and its probability was 0.2. So 2 times 0.2 plus, and then just proceed down the distribution. 3 times 0.1 plus 4 times 0.06 plus 5 times 0.04. So as we work through those, 1 times 0.6, well, that's pretty straightforward. That's just 0.6 plus 2 times 0.2 is 0.4 plus 3 times 0.1 is 0.3 plus 4 times 0.06 is 0.24 plus 5 times 0.04 is 0.2. So then we add those all up. 0.6 plus 0.4 is 1. 3 and 0.24 is 0.54. Plus 0.2 is 0.74. So we get 1.74. And that's your average. This is the average or the mean number of attempts to pass this driver's test. And this might seem a little odd. So this means on average, the students required 1.74 attempts to pass. So what you'll recognize is that's not really a valid number of attempts. I can't take 1.74 tests. And that's okay. So the average does not have to be one of your x's. Does not have to be 1, 2, 3, 4, 5 in this example. What this means is you'll have people who only needed 1 or fewer attempts. Well, there is no fewer. So there's people who needed 1 attempt, and there's people who needed 2 or more. So 2, 3, 4, 5. So those 2 sets of numbers, 1 and 2 or more, that it kind of balances out around 1.74. So this is just describing what that distribution looks like. So it's okay to have values for the average that are not actual possible values. Okay? It's just kind of describing the distribution of the other values. So that's how you find the mean. So this is that thing we skipped a couple pages ago, that weird formula with the Greek letters. All that you're doing is taking each little x times its probability. You're doing that for each one, and you're adding them all up. And that gives you the mean. So when you add up all of those products, that's the mean. Okay. And what about the median? So the median, its interpretation hasn't changed. The median still means what value of the random variable cuts the data set in half. So half of the time, students needed this number of attempts or fewer to pass. Half of the time, students needed this number of tests, whatever it is, the median, or more to pass. So this has to be a value of the random variable. This has to be a little x. And we want the little x that splits the distribution in half. So as we saw with the written out data, that's probably a 1. So the 25th number, since that's half of 50, will be a 1. But how would you get that if you didn't have all the data? If you only had the table or if you had the chart? So essentially what we're looking for is, when do we reach or surpass 50% of the distribution? At what little x did we reach or pass 50% of the distribution? And we can see here that that happens when x is 1. This is 60% of the distribution. So somewhere in here we've passed the 50% mark. The 25th person out of these 30 was the median. So that happened when x was 1. So the median is 1. X is 1. If you're more visual, then what you can do is you can think about these bars being empty and that you're going to fill them up with water. So say that you have, I don't know, 1 gallon of water. As you start to fill up these bars, when do you use half of your gallon? Well, if you start filling up the first bar about here, you've reached your half gallon. That's 50%. And you've used your half gallon within that first bar when x was 1. So you've reached the halfway point when x was 1. That means 1 is the median. If you had started filling up the bars from the other end, you'd fill up the 5th bar, so you'd use 4% of your gallon, still plenty to go. Then you'd start filling up the 4th bar, so you've used an additional 6. So now you've used up 10% of your gallon, still plenty, haven't reached 50% yet. Start filling up the 3rd bar, another 10%, so now your total's 20. Fill up the 2nd bar, 20% more, so you're at 40%. Then you start filling up this 1st bar, and you use half of your gallon somewhere down here. So still that halfway point is happening within the 1st bar when x is 1. So again, that tells us the median is 1. Okay? So we're just looking for the halfway point. When do we use up half the distribution? For the mode, that's pretty straightforward. Again, this has to be a value of x. The mean can be anything, but the median and the mode have to be one of your values. So what the mode is which value of the random variable, which little x, occurs most frequently. Or, in other words, which one has the highest probability of occurring. Well, as we look at the probability distribution, we see that the biggest probability is 60%. The most common number of attempts, the most common little x, is again 1. Most people needed 1 attempt to pass the test. Therefore, that's the mode. There are formulas for variance and standard deviation, as I mentioned, but we're going to skip these. Okay. So I think what I'm going to do, we'll have to figure it out, but for this problem, let's find the mean, the median, and the mode sort of together or individually during our meeting tomorrow. Oh, and I guess I'll call it WebEx for now. So you can do this ahead of time if you want. So here's your probability distribution. I want you to find the mean, the median, and the mode. So we'll work through this one tomorrow together, just to try to figure it out. Find a way for you to provide solutions to my questions. Find a way for me to present solutions. Yeah, I don't know. We'll figure out how to do that. So we'll end here. It's been a little over an hour. So again, what's going to happen in our WebEx meeting tomorrow, hopefully you've viewed this lecture ahead of time. So I'll be there for the full 2 hours, and you can kind of think of it like an office hours type thing. Pop in, ask questions. Do you need to go over some examples from chapter 6? Oh, by the way, this is where exam 2 ends. So all of chapter 5 up to this point can be on exam 2. So pop in, ask any questions you have about this, homework 8, anything previous. We'll talk about that. We'll talk about the exam a little bit and review for it. Questions about this electronic lecture stuff, whatever. So I'll be around for the roughly 2 hours to answer any questions you have. So I'll talk to you tomorrow.